In this video, I'm going to go over the material in section 11.4. So in this section, we're going to learn about sample space and how to determine the sample space. So the list of all the possible outcomes of an experiment is called the sample space, and each individual outcome in the sample space we call a sample point. And what we use to determine the sample space is called the fundamental counting principle. And we use this to determine the number of outcomes in a sample space. And basically what it says is if we do two experiments, one following the other, let's say, for instance, we flip a coin and then we roll a die. So if the first experiment can be performed in M ways and the second one in N ways, then the two experiments in that order can be performed in M times N ways. So again, in my example I just gave you, if we flip a coin, we have two outcomes, head or tail. And when we roll the die, we have 6 outcomes. And so we can create a picture, which is really helpful. It's called a tree diagram to show the sample points. So if you notice in my picture here, what do we have? We have the possible outcomes first from flipping the coin, a head or a tail, 2 outcomes. And then rolling the die, we have 6 outcomes. So 2 times 6 gives us 12 outcomes. And across the tree, we can list each of the sample points in the sample space. So head 1, head 2, etc. And then we have tail 1 down to tail 6. So we have 12 outcomes. And this is really helpful when you're working some probability problems because you can look at the sample points and count up the ones that fit the particular probability problem that you're working on. And remember also, it's important if you're sampling with replacement or without replacement. And we'll talk about that in one of the examples I'm going to go over in this week's materials. The other important concept from this section are the problems called at least problems. So the problem of an event E happening at least once plus the probability of the event E does not happen has to equal 1. And that leads us into this rule. The probability of an event happening at least once equals 1 minus the probability that the event does not happen. And this is going to be very useful for certain types of probability problems, as we'll see in the examples from today's lesson. All right, so let's take a look at the first problem. A restaurant offered salads with 3 types of dressing and 4 types of toppings. How many different types of salads can be offered? So we can use that fundamental counting principle. And we know there's 3 kinds of dressings and 4 kinds of toppings. So 3 times 4 gives us 12. So there's 12 different types of salads that could be created. All right, so now we're going to do a problem where we have a hat with 4 marbles. 1 red, yellow, red, blue, and green. We're going to pick 2 randomly without replacement. And first we want to determine the number of sample points in the sample space. So the first time I go in to pick, I have 4 marbles to pick from, 1 of each color. I'm going to take it out. I'm going to put it aside. I'm not going to put it back in before I pick the second marble. So when I go to pick the second time, I only have 3 marbles to pick from. So I have a total of 12 sample points in my sample space. Now I want to construct a tree diagram. Now on your homework in my math lab, these are going to be multiple choice questions. And I went ahead and I created, I created the tree diagram ahead of time. And let's take a look at it. So the first time we go in to pick, we have 4 marbles to pick from, yellow, red, blue, and green. We're going to pick one. So if we pick the yellow, we're going to put it aside. When we go back in the second time, we have a red, blue, or a green to pick from. Likewise, if we picked a red marble first, we take it out, we put it aside, and then second marble could be yellow, blue, or green, and so forth. And then there's my 12 sample points that I calculated in the first part of the problem. Now we're going to answer some questions using the tree diagram. So let's move all the way down on our sheet here, and let's determine the probability of selecting exactly 1 red marble. Okay, so we know there's 12 outcomes, so that's going to be my denominator. So I'm going to look at my tree diagram, and I want to count up how many outcomes have at least 1 red marble. So I see 1 here, I see 3 here, so that's 4, 5, and 6. So 6 out of 12, or 1/2, or 0.5. All right, the second question I'm going to pose is determine the probability of selecting at least 1 marble that is not red. I'm going to look at each of my 12 outcomes and say, does it have at least 1 that's not red? Well, this one does, and so does this one, and so does this one. Okay, this one, all 3 of these have at least 1 that's not red. These all have 1, and this actually turns out to be all of them have at least 1 that's not red because of the sampling without replacement. And so my probability is 12 over 12, or 1. And I think I have one more. Determine the probability of getting no green marbles. All right, so again, we have 12 total to pick from, so that's going to be our denominator. So how many of my outcomes don't have green marbles? So let's take a look and see. There's 1, 2, 3, 4, 5, 6, and all the rest have green. So this is 6 over 12, or another 1/2, or 0.05. 0.5 rather, not 0.05. All right, let's try some other problem. Okay, we're going to do a card deck problem this time. And this time we're working with, sometimes in statistics we use pinochle, sometimes we use poker decks, which have 52 cards. A pinochle deck has 48 cards. We're going to draw 2 cards at random, and we're going to determine the outcomes 2 ways, with replacement, and then we'll do it without replacement. Okay, so we want to figure out the number of sample points. Okay, so when I do with replacement, the first time I go in, I have 48 cards to pick from. I'm going to look at my card, write down what it is, I'm going to put it back in, and I'm going to pick again, and I still have 48 cards to pick from. So the number of sample points here is going to be 48 times 48, which I can work on my calculator. So 48 times 48 gives me 2304. Now, we're also going to do this without replacement. So the first time I go in to pick, I have 48 cards to pick from. I'm going to pick the card. I'm going to put it aside. I'm not going to put it back in. So when I go back to pick, I only have 47 cards to pick from. So if you notice, when you're sampling without replacement, you're going to have less sample points. And this time we have 2256. All right. So now this time we're going to have a home movie theater system, and you're going to purchase 3 parts to it. You're going to purchase a Blu-ray player, a receiver, and a speaker system. And here's the options that you have. So the first question is, how many sample points do we have in the sample space? So in other words, we're going to multiply the number of ways we can pick the Blu-ray player times the number of receiver options times the number of speaker options. So we see 4 for the player, the Blu-ray player, 3 for the receiver, and 2 for the speaker. And so I have 24 sample points. And now we want to construct a tree diagram. So again, tree diagram, I went ahead and I did this ahead of time. So here's my tree diagram. It's a pretty complicated one this time. So first we go in and we do, I'm sure I've got it right way up. We do first the receiver, and then we do the, what was next? The Blu-ray player, and then the receiver, and then the sound or speaker system. Okay, so we have 24. If you look over here, there's all the combinations in the tree diagram. All right, so we have the tree diagram. Now we want to do the probability of selecting a Blu-ray player. So if I go and look at Blu-ray player, Sony is over here. So I'm going to look at my tree diagram. So again, remember I have 24 outcomes. So how many of these outcomes have a Sony, which is going to be in the first spot, Sony. So if I go down here and look, here's where Sony comes in. So all of these outcomes here, 1, 2, 3, 4, 5, 6, have a Sony. So it's going to be 6 over 24, or 1/4, which is also equal to 0.25 if we want to do the decimal. Determine the probability of selecting Bose speakers. Okay, Bose speakers are over here, Bose speakers. And actually, we don't even really need the tree diagram, because we notice that either a system has Bose or it has JBL. So out of the 24, and you can verify this by counting, half of them are going to have a Bose speaker, because there's only 2 options for the speakers. And then finally, the probability of getting a Sony Blu-ray and Bose speakers. So Sony Blu-ray, let's take a look here. So Sony Blu-ray, remember, Sony's at the beginning, and a Blu-ray. So we're focusing here on Sony and, what was my other option? The Bose speaker. So Sony in the first spot and Bose in the last spot. So here we have 1, 2, looks like 3. So this is going to be 3 out of 24, or 1 out of 8. All right, last 2 for this section. The frequency setting for a garage door opener is determined by the positions of 9 switches, each of which can be set to plus or minus. How many ways can the switches be set? Okay, so we have 9 switches. 1, 2, 3, 4, 5, 6, 7, 8, 9 switches. And how many positions do we have for each switch? Plus or minus, so that's 2. So we have 2 positions for each. So fundamental counting principle, we're just going to multiply the ways each of the experiments can happen. So this is just 2 to the 9. or on my calculator, and again, you want to make sure you know where your exponent key is, 512 different ways that we can set those switches. And last one. Sports shop sold tennis rackets 4 different weights, 3 different types of springs, and 3 different grip sizes. How many different rackets could they sell? Fundamental counting principle again. 4 times 3 times 3. 4 times 3 is 4 times 3 is 12 times 3, so 36. So 36 different rackets that they could set. So hopefully this will help you on your homework. And like I said, in your homework, for the ones with the tree diagrams, they're going to be multiple choice questions where you have to click to open up the question answer to see the tree diagram they're proposing. I don't think you'll have any difficulty with those. Remember how you create a tree diagram, and I think that'll be pretty easy for you to figure out.